Hey, so in this video, we are going to specifically be looking at the creation and solving of inequalities. So inequalities is first introduced in 7th grade, and it's kind of one of those things that if you don't use it, you kind of lose it. So we're going to recap and review to ensure that we are in a good place with inequalities. So first and foremost, we're going to go ahead and write our title, Creating and Solving Inequalities. And we need to understand that an inequality is a statement that compares two expressions that aren't strictly equal. Now, there are some symbols that have that equal to it, but this is kind of giving that range of numbers that are less than this or numbers that are greater than this. And that's where we get in our 5 different symbols. All right, so these 5 symbols are what is used with inequalities. Many of you guys have seen these symbols before, so they are common to you. So we're just going to jot them down to make sure we know what is going on. So we have our less than symbol, our greater than symbol, less than or equal to, greater than or equal to, or not equal to. Now, there are some cases where the two sides are not equal, and simply put a slash through the equal sign says that. All right, please keep in mind for or equal to's, there is the bar that goes underneath them, so that way you can tell which one that you are working with. All right, and then a solution to an inequality is any value that makes that inequality true. It's not just one answer like in equations. You can have a series of numbers, decimals, and fractions that will be able to satisfy any of them. All right, so when we record these answers, the interpretation sometimes is a little funky. So we're going to make sure we can do that to the best of our ability. All right, so the next thing that we need to kind of focus on is how do you read inequalities? Many times these symbols are like, yeah, less than, yeah, greater than. But when it's written as a final answer and you have a variable tied to it, this is where we actually have the most mistakes made from it. Okay, so we're going to go ahead and we're going to write X and then the symbol 10, -8, and then this symbol and X. And I'm not going to read it out loud because that would just be silly and not give you the answers. All right, so I want you to note, I don't know if you can see, but I put little dots on the side that has the variable. So we need to ensure that we are reading from the variable, which means whatever portion of the sign is closest to the variable is how we read it. So for instance, the mouth is opened and it is close to the X. So that means we would read this as X is greater than 10. So we would read this as X is greater than 10 because the mouth is open towards the X. In this other example, we have -8 and we have X on the right, and this actually confuses a lot of people. Notice I put a dot closest to the X touching that symbol, and notice it's closed, which means we're going to be dealing with small or less than. So we actually read this as X is less than -8. Okay, so again, that is probably one of the most common mistakes that we find when reading these, is you always read from the variable and you read the sign that direction. So in this case, we would actually read right to left. Right? And then finally, the last thing that I want to point out is to solve. We do the opposite operation. We do exactly the same thing that equations did. The only difference, if we multiply or divide by a negative, we flip the sign. And that's only if you multiply or divide by a negative. If I multiply or divide by a positive, it's good. It's fine. It's only when I do those two things that we have to worry about it. So we're going to go ahead and prove that so we can kind of see what's going on with all of this. So let me kind of move my papers. All right, so you can see this. Sorry, let's get ourselves organized. All right, so we're going to go ahead and we're going to prove this. Okay, so there is some proof behind it. All right, so I have the same sequence all the way through. We have our 7 is greater than 5. And we're going to do positive, negative, multiplication, and division because I want to prove this rule and to why you need to flip that sign. All right, so one of the things, okay, is we are going to go ahead and we are going to add -2 to both sides. So we're going to add -2. All right, so by adding -2, we get 7 plus -2 is going to make 5. 5 minus 2 is going to make 3, and we're going to bring our sign down. Okay, and it does, in fact, it's true. So therefore, adding a negative stays the same. All right, so let's take a look at this next one. We're going to subtract -2 from it. So in subtracting -2, all right, and sorry, I have some of these done already, so we're going to kind of swivel and move. All right, 7 minus -2, minus negative really means plus, is going to get us 9. And 5 minus -2 is going to get us 7. So that's going to, again, create this instance of a true statement. 9 is greater than 7. All right, if I go to multiplication, I'm going to notice 7 times -2 is -14. And 5 times -2 is -10. And if I bring that sign down, -14 and -10, those are not right. -14 is not bigger than -10, which is why we have to roll that sign over when we multiply by a negative. And then if we look at division, 7 divided by -2 is going to get us -3.5. And 5 divided by -2 is going to get us -2.5. Those are halvesies. And if I bring down that symbol again, -3.5 is not bigger than -2.5. So again, we need to roll that sign over. Now, you can typically see it in a problem done like this, and you're like, yeah, I totally see it, flip the sign. However, when you're solving and when you're doing variables, you don't notice it. So you might need to check your answer at the end to ensure that you're doing okay. All right, so let's take a look at this first example. Cover this other one. All right, so we have 3x minus 5 is greater than 6. So that is a fact. So the question is, what does x have to be in order to make this true? Well, we're going to solve just like we would if this was an equation. So the opposite of -5 is +5. So we're going to go ahead and we're going to add 5 to both sides. Bringing it down, we get 3x is then greater than to 11. I just added 5, so the sign stays exactly as it is. Well, to get 3 by itself, we're going to go ahead and we're going to divide by 3. So again, don't go, but I'm dividing. No, that doesn't matter. I'm dividing by a positive number. This is positive. So that means my sign is going to stay as is. And so when I do my division, I'm going to say, well, x has to be some number that's bigger than 3 2/3. Now, what number is bigger than 3 2/3? So you might say 5. Well, I'd used 4, but true. I can plug it in. I could say, well, a number bigger than 3.1 or bigger than 3 2/3 is 4. And 3 times 4 is 12. And 12 minus 5 is 7. Yep, 7 is in fact bigger than 6. All right, let's take a look at this in a different way. And all I did is I changed this +6 to a -6. Okay, so all I did was change the +6 to a -6. So again, the first thing that we did is we add 5 to both sides. We get -3x is greater than 11. I then divide by -3, and this is where we have the warning. I'm dividing by a negative. Warning, warning, warning. You got to flip that sign. So while we still get our 3 2/3, that is now negative, and my sign had to roll over. So again, we need to check an answer. So what is smaller than -3 2/3? Well, -4 is. So I can plug -4 into the story, and -3 times -4 is 12, and 12 minus 5 is 7, and 7's still bigger than 6. If I would have flipped this and I would have said, well, x has to be greater than this, I could have tried the number 3. Well, 3 times 3 that's negative is -9, and -5, that would not work out. We would not get a bigger number than 6. Okay, so we need to make sure that we're checking our answers and seeing everything that comes into play. All right, so that's kind of the solving element of it. The other component of it then is story problems. And I know we don't like story problems. I'm one that doesn't like them either, but we still have to be able to understand them and do them because we actually live most of these problems. All right, so here we have Nora. And Nora's planning a birthday party, and it's planning a birthday party for her sister. Her budget is $50. There's going to be 8 little people that attend, and she has to pay $10 for the cake. So she's wondering if she buys party favors, how much money can she spend on them, assuming that the same kid gets everything, the same things. Okay? So again, her budget's $50. Whenever I set up equations for this, I always start with what it equals. So in this case, my budget is $50, and we're in inequality land. So while I could spend $50, can I spend more than it? No, I can't. So that means my inequality has to be less than or equal to 50. I have to spend under or equal to that $50. Good. Well, I also know I'm spending $10. I'm spending it no matter what to get her a cake, because you can't not have a cake. So I know I'm dealing with that $10. And now I have 8 kids, each getting a party favor, and I don't know how much that party favor is yet. So here we would have 8, and then your variable. And in this case, I'm going to use an F to stand for favor, for party favor. So when it says write an inequality, that's what it's asking for. It's asking, what is the setup to solve this? So now we're going to go into solve mode, and we're going to say, okay, well, I'm going to subtract the $10 for the cake. So my 8 party favors has to be less than or equal to $40. And then to solve this, which you guys all know, is we're going to go ahead and we're going to divide by 8. So each party favor has to be less than or equal to $5. And then we would declare our answer. She could spend, I can spell, $5 or less on the favors. So again, start with what that ending is, decide the inequality symbol, and kind of build it backwards. All right, let's go ahead and take a look at another example. All right, we have Trina. Hi, Trina. Okay, Trina is deciding that she is going to buy 12 shirts for the drama club. She's going to choose a style for the blank shirt and then pay an additional charge of $2.75 for each shirt to have the club logo put on it. If she cannot spend more than $99, how much can she spend on a blank shirt? All right, so this one, kind of tricky. Now, I will say I enjoy ones like this because it kind of makes you think about the system altogether and how all of it works. So let's take a look. So first and foremost, let's start at the end and how much she can spend. So she cannot spend more than $99. So that means she is spending less than or equal to $99. She can't spend more than it, but she can spend $99. Well, I know that I'm going to be buying 12 shirts, right? That's a for sure. There's going to be 12 of something. So I'm buying 12 shirts for an I don't know cost, but each of those shirts also has a $2.75 on it. So am I paying $2.75 just once? I'm going to be paying it 12 different times. So I know 12 is going to get multiplied by that 2.75. I also know that 12 is going to get multiplied by whatever that shirt costs. So since 12 is going to be multiplied by both of those, there's going to be parentheses. So 12 is going to be my shirt cost. And I'm also going to have 12 of that $2.75. Now, I could certainly combine this, and I could have said 2.75, but I can't really do it's plus. So now I have to rainbow it. Because think about it, solving-wise, I have to pay $12 per shirt, or 12 shirts, I'm sorry. But then I also have to pay whatever 12 times this cost is. So we're going to pick up our handy-dandy calculator, and we're going to say, well, if I have 12 shirts, and it's going to cost me $2.75 on each shirt, all right, I got to pay $33 to put my club logo just on the shirts. That still has to be less than or equal to the $99. So then from here, I'm solving. I'm going to go minus 33 on both sides. So my 12 shirts has to be less than or equal to the $66. And then I'm going to go ahead and I'm going to divide from here the 12. So my shirts have to be less than or equal to $5.50. Because when I pick up my calculator and I go 66 divided by 12, I get 5.5. And I know I'm talking money, okay? So now I have to kind of declare my answer, and I have to say, she can find shirts that are $5.50 or less. Because let's be real, do I want to spend all of the money? Probably not. All right? So I have 3 you-do problems for you. Go ahead and jot those down. Take a moment. So it says Sergio needs to buy gifts for 8 friends. He plans them to get them the same gift, and he's going to have them wrapped by the company for an additional charge of $1.50 each. If he spends at least $70, he's going to get free shipping. So how much will he need to spend on each gift to actually get that free shipping? There is also a B and a C you do. All right, so we have 4/3 times the quantity there of 6x plus 9 is less than 4. And we have -2 times the quantity of 1/4 x plus 2 is all greater than 5. All right, so go ahead, write those down, try them out, and let's see what you get. All right, so let's go ahead and see how you did. So we have our Sergio friend here. He is buying 8 gifts, all the same cost, and all of them going to be that $1.50 each. All right, which means, and then he wants to spend at least $70 for free shipping. All right, so at least $70 for free shipping. So we should have seen this. 8 times the quantity of G plus 150 is greater than or equal to $70 because I want some free shipping. So I need to spend more than that 70. All right, so to go ahead and to work through this problem, all right, we should have rainbowed. We should have gotten 8G plus, and then we have our 8 times 150, which would have gotten us 12, is greater than or equal to 70. From here, then, we should have subtracted 12 from both sides. So 8G is greater than or equal to 58. From here, then, we divide both sides by 8. So our gifts have to be greater than or equal to 7.25. So we are making a statement that he must spend at least $7.25 on each gift. Is that what you got? All right, so let's go ahead and check these next two. Okay. 4/3 times 6x. So if you were typing this in your calculator, you would do 4 ABC 3 times 6, and you would have gotten 8. Right? And here you should have had plus 12 is less than 4. You would have then subtracted 12 from both sides. So 8x is less than -8. And then we would have divided by, sorry, I changed my colors there for you, divided by 8. So x is less than -1. Now notice I did not flip the sign even though this is negative because I did not write a negative. All right, and then last but not least, we should have rainbowed here. And we should have had -2 times 1/4 is -1/2. -2 times +2 would have gotten me -2. I'm sorry, -4. I can do my math. I'm sorry. And that is all greater than or equal to 5. I should have then added 4 to both sides. So -1/2. Oh, my x ran away. X is greater than or equal to 9. And then to solve this, I would have multiplied by the reciprocal, -2. So x is greater than or equal to -18. I made a mistake. Look, I multiplied by a negative, which means my sign should have flipped. And that's going to happen. Sometimes you're going to catch yourself and you're like, oh, oops. Sometimes that happens and you just take care of business. All right? So that's how you solve inequalities and create inequality equations.